welcome to my channel. JR here at Learn Tech with JR. In this video, I'm going to discuss one of the topics that's in the AWS Security Specialty Exam, and that is the AWS IAM, or the Identity and Access Management. So without further ado, let's begin. The first agenda is I'm going to discuss the introduction to IAM. And lastly, after the discussion, I'll be demonstrating one of the fundamental features of IAM. So for our objective, after completing this lesson, you should be able to describe different types of credentials in IAM, identify the capabilities of IAM users, groups, and roles, explore IAM users and groups, and then lastly, define the different types of IAM policies. Let's define first what is AWS IAM. So basically, IAM is a web service that helps you securely control access to your AWS resources. So meaning a resource is an entity that's in an AWS account that you can work with. Examples of resources are EC2 instances and S3 bucket. You can centrally manage permissions that control which AWS resources users can access. Example for this one is control who can terminate the EC2 instances. So meaning terminate is delete. Okay? And lastly, you can use IAM to control who can access the resources, which resources can be accessed, and what can the user do to the resources, and then how resources can be accessed. So later on these slides, on the next slides, we're going to discuss all of these: who, which, and how. Okay. Here are some essential components of AWS IAM. To understand how to use IAM to secure your AWS account, it is important to understand the role and the function of each of the four IAM components. So the first one is IAM user. So a user is a person or application that is defined in an AWS account and that must make API calls to AWS products. Each user must have a unique name with no spaces in the name within the AWS account and a set of security credentials that is not shared with other users. These credentials are different from the AWS account root user security credentials. Each user is defined in one and only one AWS account. The next component is a IAM group. A group is a collection of IAM users. You can use IAM groups to simplify specifying and managing permissions for multiple users. You can't sign in as a group. You can use groups to specify permissions for multiple users at a time. Groups can make permissions easier to manage for large sets of users. For example, you could have a group named IAM admins and give that group permissions to administer IAM resources. And the third component is the IAM policy. A policy is a document that defines permission to determine what users can do in the AWS account. A policy typically grants an access to specific resources and specifies what the user can do with those resources. Policies can also explicitly deny. So later on, we will discuss more about AWS IAM policy. So be ready for that one. And next, the fourth essential components is the IAM role. A role is a tool for granting temporary access to specific AWS resources in an AWS account. A role is an identity within your AWS account that has a specific permissions. It is similar to an IAM user, but it is not associated with a specific person. You can temporarily assume an role in the AWS Management Console by switching roles. You can assume a role by calling an AWS CLI or AWS API operations, or by using a custom URL. Next, authenticate as an IAM user. Authentication is a basic computer security concept. A user or system must first prove their identity. Consider how you can authenticate yourself when you go to the airport and you want to get through airport security so that you can catch your flight. In this situation, you must present some form of identification to the security official to prove who you are before you can enter a security or restricted area. A similar concept applies for gaining access to AWS resources in the cloud. To authenticate as an IAM user, provide your account ID or alias and then your username and password to authenticate workloads from the API or AWS CLI. You might use temporary credentials through being assigned a role, or you might use long-term credentials by providing your access key and then your secret key. You might also be required to provide additional security information. When you define an IAM user, you select what type of access the user is permitted to use to access the AWS resources. You can assign two different types of access to your users. The first one is programmatic access, and the second one is the AWS Management Console access. You can assign programmatic access only, console access only, or you can assign both types of access. If you grant programmatic access, the IAM user will be required to present an access key ID and a secret key with when they make an API call by using the AWS CLI, the AWS SDK, or some other development toolkits. If you grant AWS Management Console access, the IAM user will be required to fill in the fields that appear in the browser login window. The user is prompted to provide either the 12-digit account ID or the corresponding account alias. The user must also enter their IAM username and a password. If MFA or the multi-factor authentication is enabled for the user, they also be prompted for an authentication code. So we have a separate discussion about MFA, so I believe that's on the next one. Yes, that that's the MFA or the multi-factor authentication. AWS services and resources can be accessed by using the AWS Management Console, the AWS CLI, or through SDKs and APIs. For increased security, AWS recommended enabling multi-factor authentication or MFA. With MFA, users and systems must provide an IAM MFA token in addition to the regular sign-in credentials, meaning it is separate from username and password before they can access your AWS services and then your resources. Options for generating the MFA authentication token include virtual MFA compliant applications such as Google Authenticator or Cisco Duo, or Authy two-factor authentication. Or there's what they call the hardware MFA device for generating an MFA token. So after you enter your MFA token, you will be able to access your AWS Management Console or through AWS CLI. Next, authorization is the process of determining what permissions a user, service, or application should be granted. After a user has been authenticated, they must be authorized to access the AWS services. By default, IAM users do not have permissions to access any resources or data in an AWS account. Instead, you must explicitly grant permissions to a user, group, or a role by creating a policy, which is a document in JSON format or JavaScript object notation. A policy lists permissions that allow or deny access to resources in the AWS account. So, as you can see in this diagram, say you are using you have your user, group, and role, and for each user group, they have assigned an policy, meaning for each user group or policy, they can have both full access and then read only for a specific AWS resources or services. So as you can see, example, a user has a full access to the EC2 instances, meaning they can create, delete, or read the EC2 instances. Next, a group of user can have the read-only permissions, meaning they can only read the S3 bucket. They cannot modify the S3 bucket. So it's only a read-only access. Next, authorization. To assign permission to a user group or a role, you must create an IAM policy or find an existing policy in the account. There are no default permissions. All actions in the account are denied to the user by default, meaning they are implicit deny, unless those actions are explicitly allowed. Any actions that you do not explicitly allow are denied. Any actions that you are explicitly denied are always denied. The principle of least privilege is an important concept in a computer security. It promotes that you grant only the minimal user privileges needed to the user based on the needs of your users. When you create an IAM policy, it is best practice to follow this security advice of granting a least privilege. Determine what users need to be able to do and then craft policies for them that let the users perform only those tasks. Start with a minimum set of permissions and grant additional permissions as necessary. Doing so is more secure than starting with permissions that are too broad and then later trying to lock down the permissions granted. Note that the scope of the IAM service configuration is global. The settings are not defined at an AWS region. IAM settings applies across all AWS regions. Next, we have the IAM policy. So an IAM policy is a formal statement of permissions that will be granted to an entity. Policies can be attached to any IAM entity, so meaning entities. These are the users, groups, roles, or resources. For example, you can attach a policy to AWS resources that will block all requests that do not come from an approved IP address range. Policies specify what actions are allowed, which resources to allow the actions on, and what the effect will be when the user requests access to the resources. The order in which the policies are evaluated has no effect on the outcome of the evaluation. All policies that are evaluated, and the result is always that the request is either allowed or denied. When there is a conflict, the most restrictive policy applies. There are two types of IAM policies. First is the identity based, and then the other one is resource based policy. So later on we will have a separate discussion on these two types of policies. Let's discuss first what is AWS Managed Policies. AWS Managed Policies make it convenient for you to assign appropriate permissions to users, groups, and roles. It is faster than writing the policies yourself and includes permissions for many common use cases. You cannot change the permissions defined in AWS Managed Policies, meaning they are created by AWS. So you cannot modify or edit it. The following diagram illustrates the AWS Managed Policies. The diagram shows three AWS Managed Policies. First, the administrator access, power user access, and then the AWS CloudTrail read-only access. Notice that a single AWS Managed Policy can be attached to principal entities in different AWS accounts and to different principal entities in a single AWS account. So the next identity-based policies is the customer managed policies. A customer managed policy is simply a custom policy. You can create this customer managed policy for your specific use cases, and you can change and update them as often as you like. Like AWS managed policies, when you attach a policy to a principal or entity, you give the entity the permissions that are defined in the policy. When you update permissions in the policy, the changes are applied to all principal entities that the policy is attached to. The following diagram illustrates customer managed policies. Each policy is an entity in IAM with its own ARN or Amazon resource name. That includes the policy name. Notice that the same policy can be attached to multiple principal entities. For example, the same DynamoDB Books app policy is attached to two different IAM rules. Next, the inline policies. An inline policy is a policy created for a single IAM identity, a user group, or a role. Inline policies maintain a strict one-to-one relationship between a policy and an identity. They are deleted when you delete the identity. The following diagram illustrates inline policies. Each policy is an inherent part of the user, group, or a role. Notice that the two roles include the same policy, meaning the DynamoDB Books app policy, but they are not sharing a single policy. Each role has its own copy of the policy. So when you say inline policy, so it is specifically for individual user or a group or a role. So they cannot be shared to each other. And next we have the next IAM policies we have here is the resource-based policy. With resource-based policies, you can specify who has the access to the resource and what actions they can perform on it. You can attach resource-based policies to Amazon S3 buckets, Amazon SQS queues, VPC endpoints, and AWS Key Management Service or the KMS encryption keys. So you cannot attach to a user, group, or a role. These policies grant this specified principal permission to perform specific actions on that resource and define under what conditions this applies. Resource-based policy can be a inline policies as well. And then there are no managed resource-based policies. Now let's take a look at the difference between identity-based policies and then the resource-based policies. So the first one is identity-based policies. As you can see in the diagram, you have the user 1 and user 2. For each user, they have the identity-based policies attached to it. For user 1, it has the EC2 read-only access policy. And then for user 2, it has the S3 full access to the S3 buckets. So meaning full access, the user 2 can create, delete, and then list down all the S3 buckets. And then for user 1, it can only list or read all the EC2 instances. So they different, right? So that's the identity-based policies. So meaning identity, a policy is attached to a entity or meaning the user. Next, let's take a look at the resource-based policy. So as you can see on the diagram, we have the resources of EC2 instances and then the S3 bucket. For EC2 instances, it has the resource-based policy of EC2 read-only access. So on that policy, it includes that only user 1 can only have the EC2 read-only. So other than user or user 2, it is denied. Same as the S3 bucket. So S3 bucket has a S3 full access resource-based policy attached to it, and then on that policy, it is stated that only user 2 can have the S3 full access, meaning user 2 can add, delete, and read in the S3 bucket. Other than user 2, they are denied. Hope that you get the difference between the identity-based policies and then the resource-based policies. AWS IAM Policies enables you to fine-tune privileges that are granted to an IAM users, groups, and roles. When IAM determines whether a permission is allowed, IAM first checks for the existence of any applicable explicit denial policy. If no explicit denial exists, it then checks for any applicable explicit allow policy. If neither an explicit deny nor an explicit allow policy exists, IAM reverts to the default, which is to deny the access. This process is referred to as an implicit deny. The user will be permitted to take the action only if the request action is not explicitly denied and is explicitly allowed. It can be difficult to figure out whether access to a resource will be granted to an IAM entity when you develop an IAM policies. Next, we have the IAM groups. So what is an IAM group? A group is a collection of IAM users. IAM groups offer a convenient way to specify permissions for a collection of users, which can make it easier to manage the permissions for those users. For example, you could create an IAM group that is called the developers and attach an IAM policy or multiple IAM policies to the developers group that grant the AWS resource access permissions that developers typically needs. Any user that you then add to the developer group will automatically have the permissions that are assigned to the group. In such a case, you do not need to attach the IAM policy or an IAM policies directly to the user. If a new user joins your organizations and should be granted developer privileges, you can simply add that user to the developer groups. Similarly, if a person changes the jobs in your organizations, instead of editing that user's permissions, simply remove the user from the group. Unimportant characteristics of an IAM groups are: first, a group can contain many users and a user can belong to the multiple groups. The second, groups cannot be nested. A group can contain only users and a group cannot contain other groups. And lastly, there's no default group that automatically includes all users in the AWS account. If you want to have a group with all account users in it, you need to create the group and add each new user to it. Next, we have the IAM roles. So what is an IAM role? A role is an identity that you can create in your account that has a specific permissions. A role is similar to a user because it is also an identity that you can attach permissions policies to, and those permissions determine what the identity can and cannot do in AWS. However, instead of being uniquely associated with one person, a role is intended to be assumable by anyone who needs it. Also, a role does not have standard long-term credentials such as a password or access keys associated with it. Instead, when you assume a role, the role provides you with temporary security credentials for your role session. You can use roles to delegate access to users, applications, and services that do not normally have access to your AWS resources. For example, you might want to grant users in your AWS account access to your resources they don't usually have, or grant users in one person or one AWS account access to resources in another account. Or you might want to allow a mobile app to use AWS resources, but you do not want to embed AWS keys within the app, where the key can be difficult to rotate and where users can potentially extract them and misuse them. Also, sometimes you may want to grant AWS access to users who already have the identity that are identified outside of AWS, such as in your corporate directory. Or you might want to grant access to your AWS account to third parties so that they can perform an audit on your resources. For all of these example use cases, IAM roles are an essential component to implementing the cloud deployment. Now let's jump into the demo of AWS IAM. So that's next. See you there. Thank you.